Hey, what's up, guys? Chung here. And so this time, let's take a look at this problem. Number 911, online election. It's a medium problem. So, uh, you're given like basically, uh, two parameters, right? The first one is a persons, list all the persons, and the second one is the times. So, so the ice element of a person means that at the time, at the time I this person I got voted by one, and now it asks you to implement like this queue method which will be giving you with like the input as a time here. Basically, it's asking you to return what's the current what's the leading person at this time here, which is the t. Okay. Mm, oh, and in case there's a tie, the most recent vote among tied candidates wins. Okay, so some examples here, like you're given like this person's array, right? So basically there are like 7 votes, and here are the times, right? Like each person got the times of the votes happened. Okay, yeah. So since it tells you that one of the constraints is that the time is strictly increasing, right? So I think this is like strong hint, right? So every time when you have a T here, right, you just need to search the answer. Okay. I mean, a naive way is like what? It's like for each of the T here, right? For each of the time here, we just loop through all the persons and the time and the votes, right? At the time of this T, which is smaller or equal than this, right? And then so for each of the call of Q here, we loop through all the votes before this T, and then we calculate the voted person, right? But that would be like time consuming, right? Because so for each of the Q, the call here, right? There's like it's like 10, sorry, 10,000, right? So how many times of yeah, there's gonna be 10,000 calls of the queue, and each of the time we'll loop through all the persons, right? That's going to be 10,000 times 5,000. Yeah, which will be most likely TLE at least very slow. Okay, so a better way is we pre-calculated basically for each of the time here, right? We pre-calculated uh at each of the times here who is the leading person. Okay, and then we store them into like a hash table. And every time when we have a t here, right, since the times remember is strictly increasing, we can simply use a binary search to find which is binary use the t as a key to binary search the times that uh, we need to use to find our answer. Since we have already processed for each time, right, we who is the leading person, we simply return that value. Okay, yeah, that's pretty much it is. Okay. So for codings, right? Uh, so the first one is the self leadings, right? So I'm gonna create the leadings, right? Like a hash table, right? That's the first things we want to use to search basically. That's gonna be our hash table. And the second one is now let's populate that hash table. Okay. Basically, we're gonna have like a n equals to the length of person. So how do we populate this hash table, right? At each point, at each time, okay? Basically, in range n here, we just need to maintain like current max vote, okay, right? And mm, the person is the person's I, right? And then the time is the times I. So, mm, yeah. So besides that, we also need like a variable to maintain to keep counting, basically counter, right? The counter of the votes for each person, which will be the votes. It's gonna be a hash table, right? Uh, default dictionary. The default is integer. Okay. Now, uh, hmm, so this one is going to be key and value. Okay, so now let's say we have a, well, actually, you know what? Actually, this the leadings here, we don't even need to store a dictionary, right? Because we all we need to do is, since the sequence, right, at each times will be aligned with the time sequence here. So all we need to do is we just need to store which person is the leading person at this time, right? Basically, a simple list will be enough. Okay, and basically if not, right, self, basically if there's empty here, right, we simply do what with just the self dot leading. Okay, append the current person, right, because and also the current max vote is 1, right? So that's else what? Else the uh yeah, actually we don't even need this time here. Okay, but I'll leave it here. Maybe we can just also remove this one. Okay, so now the else if, right? Else if the uh yeah, sorry, self dot votes, the key is a person, right? And then plus 1. Okay. Else if the self dot votes, if the current person's vote is equal or greater than the current max vote. Okay. So why we do a equal here, right? So because it says if there's a tie, basically, if there's a tie, then the most recent vote wins. Basically, if there's already like 2 votes, and that person one have 2 votes. Okay, 2 votes. Now, at the same position, at this round, right? Let's say the person two, after increasing 1, we also have 2 votes. So at this time here, the most the leading person should be P2, not P1. That's why we do a greater or equal than this. Okay, self dot leadings append uh, append P. Okay, yeah, because this is the new person, and we also need to update the current max. Okay, it's going to be self dot votes dot P, right? We also need to update that. Else, so the last one is the current people doesn't it's not the leading person. Okay, which means what? Which means the last person is the leading person. Okay, so what's the last person? So the last person is the append uh, self dot leadings dot minus 1. Okay, basically, so it means that if the current one does not have the maximum, the most vote, then at this time here, the previous one, the basically the so whatever was the leading person, it will still be the leading person at this time. That's why we use the last one, the last element. Okay, yeah, and of course there's no point to update the current vote. Okay, yeah. So after that, I mean, we have the leading persons at each of the times here. Okay, yeah, so that's that. And now we can implement this queue here, right? Basically, what do we do this, right? We do a binary search at the time here. But how do we do the binary search? Let's say we have 1, 2, no, let's say we have 1, 5, 10, and 15. Okay, so let's say the time is 3. So what's for the time of 3 here, right? And the time we need is we are looking for is 1, is this one. So that if we use a bisect, if we use a bisect and then bisect uh so bisect left, let's see if we can use left. Okay, if we use the bisect left, so the source is okay. So to binary search, we also need to save these times. So the sources is the times itself. Okay, if we search the times with the t here, right? If we do a bisect left, then if we search 3, it will give us 1. The index will be 1, right? The index. But instead, we need 0. Okay, that's why we need to do a -1. But how is the left the correct one? No, right? What if the search is like uh, a 1? What if we're searching 5? Okay, since we're doing a bisect left -1, right? If we're since we're doing a -1 here, if we're doing a left here, when we search 5, so it means that if it's the same one, if it's the same numbers, it will give us the index on the left side, which will be uh, which will be 1, right? Basically, it will insert at this position, right? So this is always also be 1, but we what we really need is we are hoping is to give us 2, right? So that the 2 minus 1 will give us the 5, the index of 5, which is 1. That's why instead of left here, we need to use right. So which means when we're searching the same index, same value of the same times here, we just need to get the index +1 so that when we do a -1, we can get the correct answer here. Okay, basically that's the index, right? So we simply need to just return the self-leading, right? The leadings of the index, because the index, because we have the same length of the leadings at each time here. As long as we find the times we need, we just need to use this index to find the leading persons at this moment. Okay, so I think this should just work. uh, Leadings, okay, yeah, run it. Cool, submit. Hmm? Yeah, cool. Yeah, it's pretty straightforward, like medium problem. So the only thing here you guys need to like be to to notice that is just to use a binary search, right? And so to be able to do a binary search, the key is the time, but and we also we need to since it doesn't ask you, it didn't ask you the time, right? It asks you to return the leading person at this time. So that's why besides the binary search, we also need to construct, right, the data, basically the data at each time, so that we can just simply search that. Cool. I think that's pretty much it is I want to talk about for this problem. Yeah, thank you so much for watching the videos, guys. Stay tuned. See you guys soon. Bye bye.